This is exam revision, past questions. Question number 1. Take a look at these three, X, Y, and Z, and determine the name of each image. When there is no spaces, we call it the space-filling model. And when there is balls and sticks, we call it the ball and stick model. Correct answer is C. Which of the following elements is atomic? The elements below that are yellow are called diatomic elements. Diatomic elements exist in twos. The elements in pink are called polyatomic elements. Poly means many. Every element that is not yellow or pink is called atomic. Answer is calcium. Calcium phosphate. What type of compound and what's the formula? Calcium is here, it's a metal. Phosphate has P and has O, which is non-metal. Ionic compounds have metal and non-metal. Now for the formula. Calcium is +2, PO4 is -3. Remember, these charges need to be balanced. Anytime we have a 2 and a 3, we are making them 6. We have 3 calcium and 2 phosphates. So we are writing the formula like this. 3 calcium and phosphate we have 2. Answer is D. Which of the following is the empirical formula for this compound? Remember, empirical formula is the simplified. Let's simplify this formula. Divide all of these numbers by 2. The formula will be C2H4O. What is the formula for sodium perbromate? Sodium is in group 1. Perbromate is a polyatomic ion, BrO4 -1. So they will come together to make NaBrO4. Now remember, per is always for the oxygen that has more, the most. Per is most. Hypo is least. Give the chemical formula for Pi. P is a nonmetal, I is a nonmetal. When we are naming nonmetal atoms, which are molecular compounds, we are using prefixes in the name. You should memorize these prefixes. So how many phosphorus atoms? Just 1. And how many iodine? 3. The prefix for 1 is mono and 3 is tri. The answer is B, because we don't say mono for the first element. Determine the number of molecules in 8.5 grams of NaNO3. Remember the mole map? We have to go first from gram to mole, then mole to molecule. To go from gram to mole, divide by molar mass. Then to go from mole to molecule, multiply by Avogadro. First, let's change gram to mole. Notice that the molar mass is given in the question. So 8.5 over 85 is 0.1 mole. Now we have to change mole to molecule. Multiply by Avogadro. 0.1 times 6 is 0.6. And then we copy times 10 to the power 23. Now we want to move the decimal 1 place to the right. So 6 times 10 to the power 22 is the answer. Consider a 10-gram sample of 3 different compounds. So you have 10 grams of this, this, and this. Which one has the largest moles? Let's start by finding the molar mass for each of these compounds. Go to the periodic table and find all of these elements. Remember, to find the molar mass, we are using the bigger number, the mass. For example, hydrogen fluoride is 1 plus 19, which is 20 grams per mole. Now we have the molar mass for each of these elements, but the question says that we have a 10-gram sample, so we want to change gram to mole. How do we change gram to mole? Divide by molar mass. So the given mass is 10, the molar mass you just found. So go ahead and find the moles for each one. So for the HF, it's 10 over 20, BeCl2, 10 over 80, MgO, 10 over 40. After finding the moles, you can see the greatest moles is 0.5 for HF. Answer is A. Which of the following contains 62% carbon by mass? You studied this formula for percent mass. Let's start by finding the total mass for each of these. Now I found the total mass for each compound. In the first compound, this much is carbon, second compound, this much, third compound, this much, and the last compound, this much. Now, you could sit and do calculations, or you could just take a look at these relationships. We are looking for something that is 62%, which means little bit more than half. 12 is half 44, so it's not going to be this one because this is going to be 50%. All right? Look at this, 12 over 16. 12 is very close to 16, so it's not going to be this one. That's 75%. Look here, 24 and 26. 24 is almost 100% of 26, so I'm not going to choose this. But here, 24 is a little bit more than half of 58, so I'm going to choose D. Or you could sit and solve all four choices. What is the correct formula for dinitrogen tetraoxide? Do you remember the prefixes? Di is 2 and tetra is 4. So 2 nitrogen and 4 oxygen. Answer is B. Mass percent. What's the mass percent of oxygen in CO2? We took a formula for mass percent. So we need the percentage of oxygen. So find the total mass and see how much of it is oxygen. All of this is oxygen. 32 grams is total oxygen. So 32 over 44 times 100. Now the question says that just to find the closest, no need to actually solve. So is 32 half of 44? What's half 44?
22.
22. So this is going to be more than half. So 16 doesn't make sense. 29 doesn't make sense. And 53 doesn't make sense because 32 is more than half. So we will choose D. Without solving, we can just see that the answer is D. Which of the following is an empirical formula? You are looking for a formula that is simplified. So the correct answer is D. Give the name for TiCO3. Ti is in the middle of the periodic table. This is a transition metal. Remember, these metals are special because you have to use Roman numerals when you are giving the charge, because they can have more than one charge. CO3, I hope you recognize it. CO3 minus 2. You should know that this is carbonate, something you should have memorized. So Ti is titanium, CO3 is carbonate. The answer is C. What is the molecular formula for this compound? Remember, molecular is not simplified. So you need to see for all of these, if I simplify it, will I get this empirical formula? Let's simplify each of these. I simplified all of these formulas, and this one is the same like this. So this must be the molecular formula for this empirical formula. So in this question, we want to know how many molecules of CH2Cl2 are in 8.5 grams of CH2Cl2. Remind yourself to go from gram to mole, we have to divide by the molar mass. Let's find the molar mass. The molar mass is 85 grams. So now let's do given mass divided by molar mass. 8.5 divided by 85 is 0.1. Now let's change mole to molecule, multiply by Avogadro. We're going to multiply 0.1 times 6, 0.6, and then carry over the times 10 to the power 23. Let's move the decimal one place. This will be 6 times 10 to the power 22 molecules. Take a look at this picture. What is represented by this diagram? If it was ionic, then you would see plus and minus. There's no plus and minus, so it's not ionic. If it was molecular compound, then you would see different atoms joined together. If it was a molecular element, then you would see more than one of the same atom. And if it was atomic element, then you would just see an element. So this is a molecular element. Let's fill this table. Give the formula or the name. Now, you need to be able to recognize if it's an acid or if it's a molecular compound. If it's an acid, then it's going to start with H. If it's a molecular compound, it's going to be two nonmetals, and this is when we are going to use the prefixes. If it's ionic compound, it's going to be a metal and a non-metal. All right, do you see any acids in the table above? Yep, the first one is an acid because it starts with H. Is this binary or oxyacid? This is actually an oxyacid, so we are not going to say hydro. Now, look at the back, SO3. What is SO3? SO3 is sulfite. We're going to change the ite to us. So this is sulfurous acid. Let's look at the second one, P2Cl5. See the periodic table. P is a nonmetal and Cl is a nonmetal. So this is a molecular compound, which means we will use prefixes. So we have 2P and 5Cl. So we will say diphosphorus pentachloride. Let's do the last one next. NaO. Here's Na, here's O. It's a metal and a non-metal, so it's ionic. So I just need to give the name of the first element and give the name of the second element with IDE. This is sodium oxide. Now let's do tin 2 oxide. Tin is Sn. Because it's a transition metal, they are giving us the charge. It's +2. And oxygen is in group 16, so it's -2. Now these charges should be balanced, and they are. So the formula is SNO. The next one is also ionic. We have potassium, which is K in group 1, so K plus 1. Hydrogen carbonate is a polyatomic ion, which you should know. Now, +1 - 1, so KHCO3 is the formula. Consider the following two elements, X and Y. The first question says, give the name of the two compounds. So X is CCl4 and Y is SO3. Let's give the name. Notice that C is a nonmetal, Cl is a nonmetal, S is a nonmetal, and O is a nonmetal. So these are molecular compounds, and we will use prefixes to give the name. The first one is carbon tetrachloride. The second one is sulfur trioxide. Part B, how many moles are in sample X? Do you remember how to change gram to mole? We should divide by molar mass. 12 plus 35.5 times 4 is 154. So the molar mass is 154 grams per mole. All right, now start simplifying. You will get 1/4, which is 0.25 moles. Now we have to calculate the mass in sample Y. Sample Y is molecule. So to go from molecule, we have to go from molecule to mole and then mole to gram. How to go from molecule to mole? You need to divide by Avogadro's number. And how to go from mole to gram? We need to multiply. I wrote divide. We need to multiply by molar mass. All right, let's start by getting the molar mass of SO3. Molar mass for SO3 is 60. Let's leave that. We're going to need it later. All right, let's go from molecule to mole. So divide by molar mass. So in the question, we have 1.2 times 10 to the 24 molecule. To make this calculation easier, we want to make the powers the same. So I'm going to move this decimal one place to the right. When I do that, this 24 will become a 23. Now it's easy, we can cancel the powers. 12 divided by 6, see how much easier that looks? It's 2. Now next step is to go from mole to gram. So now we have 2 mole, we want to go from mole to gram. We will multiply by the molar mass. Molar mass is 60. Final answer, 120 grams. All right, do your best to be able to do these calculations. It's very important. All right, pause the video and make sure you take the time to read the question. Here we have 2 samples, Q and R. Sample Q and sample R, 2 different substances. We want to determine the mass of oxygen in each sample. And then they want to know which one contains the larger mass of oxygen. 20 marks. All right, this is the very last lesson that we studied, okay? If you have a compound and you want to see the element inside. So first we have mass compound. We want to make it mole compound. So how do you go from mass to mole? Divide by molar mass. And then moles compound to moles element. This is what we were calling the mole ratio. I'll discuss that in a minute. And then you have to go from mole element to mass element. How do you go from moles to mass? You multiply. All right, this is a little bit of a long question to be answering, but you have to notice this has 20 marks on it, okay? So it's important that you're able to do it. All right, let's start. Mass compound to moles compound. So in the question they gave us, let's do CaO first. 5.6 gram CaO. I want to divide by the molar mass. You have to find the molar mass of CaO. All right, so 40 plus 16 is 56. So I have, this is the molar mass. I just found that. So 5.6 over 56. I hope you are realizing now that that is 0.1 mole. All right, good job. So you just went from mass compound to mole compound. So we have 0.1 mole CaO. We want to know how much oxygen we have. Now, because this is a 1-to-1 ratio, if we have 0.1 mole CaO, it means that we have 0.1 mole oxygen. Because it's a 1-to-1 ratio inside the formula, then however much we have CaO, we have same oxygen. So 0.1 mole oxygen. Now we need to change mole element to mass element. So we will multiply by the molar mass. The molar mass of oxygen is 16. So 0.1 times 16 is 1.6 grams oxygen. All right, so now you know the oxygen in CaO. All right, now we're going to follow the same steps to find the oxygen in CaCO4. Let's start. So first we want to change the mass of the compound to the mole. We're going to divide by molar mass. So we have to find the molar mass of CaSO4 first. So let's do that. All right, I found the molar mass to be 136 grams per mole. So I'm going to do 13.6 over 136. And I'm going to get 0.1 mole again. I hope you're noticing that the numbers, usually they're coming out like this, okay? If you notice that you're getting a very difficult number, maybe you made a mistake. Now I have 0.1 mole CaSO4. Now I want to know how much oxygen is in there. So 0.1 mole CaSO4, how much O is there going to be? So there are 4 O's. So 4 times as much. So I'm going to do 0.1 mole, and there's going to be 4 times as much O. So there's going to be 0.4 moles oxygen. And now I have the last step. I have to change the mole element to mass element, multiply by the molar mass. That's easy. So I have 0.4 moles oxygen. I'm going to multiply it by the molar mass of oxygen, which is 16. I'm going to end up with 6.4 grams oxygen. All right, I'm not finished. Okay, pay attention to the question. It says, do you agree with the student? What do you think? The student, he thinks that R contains more oxygen. Is that what you got? This is Q, this is R. Which one has more oxygen? Do you see? Sample R is on this side. It has 6.4 grams oxygen. So is the student correct? So you would say yes. You must say yes. You must say yes, I agree. Okay, this statement alone is worth many marks. You have to say, yes, I agree. All right, good luck.